Hello students, so welcome to another video. Today we are learning about logarithmic functions, so how they relate to the exponential functions, and we'll learn a lot about the characteristics of the logarithmic function. So right now you're looking at a worksheet that you were given in the class. So this is concerning graphing the exponential function, but we are actually even graphing logarithmic function along with it and see how they both are related graphically. So here we have this question, y equals 10 to the x as an exponential function. So let us draw a graph for that. So this is like 10 to the negative 4, because here you're plugging in, the values are given for us, x being an independent variable, we have values listed out. I'm using those values to find corresponding y values. So this is 10 to the negative 4 when you plug in negative 4. So this would be in a decimal point 0.0001, 10 to the negative 2, which is 0.01, 10 to the negative 1, which is 0.1, 10 to the 0 is 1, 10 to the power of 1 is 10, this is 100, 1000, so on and so forth. Okay, so what we're trying to do here is we are plotting this on this graph and see how it looks like. We have done this already in the class, but when you plot all the points, it will like shoot up like this. That's the main feature of exponential function. My curve is not that good, but if you look at this, it's going up happily this way. And now let's do the same thing, but this time I'm going to switch my x and y values. Remember what we did during when we learned square root functions, finding the inverse of quadratics and so on and so forth. We switched the values of x and y, so we have reason to do that now. So I'm going to put all my x values into my y column here. So it'll be, before I do that, I'll probably do my y values first. So this is 10 to the negative 4, 10 to the negative 3, 10 to the negative 2, there was no negative 3, so never mind, negative 2, this is negative 1, 10 to the 0, which is 1, and then 10, 100, 10,000, so on and so forth. Here, when you use your calculator, you can just use the log functionality. You have a log button there on your calculator. So you just simply plug in the value of x, 10 to the negative 4 here. It will happily tell you it's negative 4. So do that, you will get back negative 4, negative 2, negative 1, 0, you have 1, 2, 3, 1 to 4, so on and so forth. So when you plot this particular graph, you will see that this graph will go this way. I think it will go through the 1, 0 line this way. So I'm going to draw a line here to show that this particular exponential function is an inverse of this, because both are inverses to each other over this line y equal to x. You see that? So this particular logarithmic function is an inverse of the exponential function. So let's label this. This is y equals 10 to the x, and here y equals log x to the base 10. Okay, so if we go to this slide, I have done this already. So we have this graph this way. I'm going to draw it again for you, and the logarithmic function this way. My x equal to y line here. My lines and curves may not be perfect, but you get the idea. Actually, y equals x. So you see that these values are inverse of each other, right? So we have proved graphically and also using a table that the exponential function is an inverse of logarithmic function, and logarithmic function is an inverse of exponential. So now let's look at the domain and ranges. Let's compare. So he is asking here, provide the domain in set notation. You have x. Okay, let's talk about it first. You see that x values are ranging from all the negatives to all the positives. For this exponential function, this is y equals 10 to the x. Right? So that means x belongs to all real numbers. Here provide the domain in interval notation. So it is actually ranging from open interval, negative infinity to positive infinity. Now provide the range. Now he's talking about range. Is the range, or do you see any y values going beyond this graph over this line? So the graph is taking on only positive y values, and that too, it's not touching the asymptote here, which is the x-axis. Remember, asymptote is a line which the curve seems to be approaching but never touches it. So this is approaching x to the x is approaching to a negative infinity, and the curve seems to be approaching it. So that means the graph doesn't take on the value 0 at all. So our range in the set form would be y belongs to R such that y is greater than 0. Now interval notation, open interval 0 to infinity. Okay. Now, is there a horizontal asymptote? I just talked about it. So what is the equation of x-axis? It is y equal to 0. Do we have a vertical asymptote? Seems like y is like going through all the y values, both negative and positive. So y, we really do not have any vertical asymptotes. Coming to the logarithmic function, looking at the graph, what values of x is the graph taking? Is it taking negative values of x? Not at all. It's just taking from 0 to infinity, but it never accepts 0 into its function. So we would say x belongs to R such that x is greater than 0. See that? And now in interval notation, this would be 0 through infinity, open interval. Provide the range. Range would be all the y values, both positive and negative. I see that y is taking both positive and negative. So y belongs to R in this case. All right. Now in interval notation, the same thing would be written as 0. Infinity. I'm sorry, my bad. Negative infinity to positive infinity, open interval. Do you see any horizontal asymptote at all? I do not see anything. Because x is taking on all real numbers, there is no horizontal asymptote, so none. Is the graph taking a vertical asymptote? Is the graph touching the x-axis at all? No. So the vertical asymptote is the y-axis. And what is the equation of y-axis? X equal to 0. So whenever an asymptote is asked for, please provide an equation, not a value. So plot the line y equal to x, which we did. What do you notice about the function? They are inverses to each other. Okay? Now, let's look at this question in the worksheet that I have provided. I have almost answered all the questions except for this is a transformed function. The transform, now compare this with y equals log x, right? Y equals log x is our parent function. So when you look at the parent function, now to talk about domain and range of the transform function, we need to know how the graph looks like. let's go up and see how the original y equals log x looks like. It never touches the y-axis. So similarly, this one is going up 2 units and going right 1 unit. So that means it will never touch this line. I'm sorry, this line is not perfect. It never touches x equal to 1 line. So your graph really goes this way and goes to the infinity. And also, since it is moving up, so it should move up 2 units. So what could be the domain? So why do we need this transform function details? Because we need to answer questions for the domain and range. How is the domain? I mean, how is the graph behaving so we can define the domain? You see that the domain is never taking, the graph is never taking x values below 1. So that means x should be greater than 1. That's why we have x is greater than 1 here and not equal to. The range, again, it's taking on all y values, so we have range as all real numbers. Do you think we have an x-intercept? Yes. Do we have a y-intercept? The graph is not even touching the x equal to 1 line. How would it go even to the y-axis? So there is no y-intercept. So there is no y-intercept. And asymptote is x equals 1, right? The transformations, the graph moved horizontally right 1 unit and vertically up 2 units. So that is how you answer questions like these. So let's go to this question where you are asked to find the inverse of the exponential function. So this is already done for you. I'm going to do something different, or let's see, we have y equals 4 to the power of x plus 3. Okay, so the first step would be to switch x and y. So this becomes x equals to 4 to the power of y plus 3. Now we have to solve for y. For that, y is in the exponent. To bring it down to the base, we have to apply the log rule. So 4 is going as a base. So this is what is called log rule. If I have a function like y equals 2 to the x, to find the logarithm of it, we roll this 2 to the base of the log. So all we do is say it as log y to the base 2 equal to x. See how it has rolled? So similarly, I'm going to apply log rule here. So it is log of x to the base 4 is equal to y plus 3. Now I want to isolate y, so I subtract 3 on both sides. So this is negative 3 plus log x to the base 4 equal to y. This is your answer. Another question might be as you are given a logarithmic function and you need to find inverse of it. So let's look at that kind of question, which is, let's see the 19th question in your worksheet, which is y equals log of x minus 1 to the base 3. So x minus 1 is in the parentheses, so even negative 1 is inside the log. So this time you have to switch x and y again. X equal to log y minus 1 to the base 3. Now apply the log rule in the reverse way. This time 3 goes as the base of this exponent. So this 3 now comes here. X goes as an exponent. Remove the log and you're left with y minus 1. All you have to do is add 1 on both sides to isolate y. So y is 1 plus 3 to the x. So this is your answer. This function, exponential function, is the inverse of this logarithmic function. Okay? This is how you work with logarithms. We'll know more about properties of logarithms and other laws in the next chapter. For now, this should be sufficient for your characteristics of logarithm functions. Thank you so much for watching.